So we're going to now talk about the addition principle, also known as the addition rule. So let's read this definition here. Venn diagrams can be used to illustrate a very important rule that will enable us to calculate probabilities for more complex events. If A and B are two events in a sample space epsilon, and the A intersection of B is not equal to the null factor, so this just means there is a point in which they overlap, then the relationship between them can be represented by a Venn diagram as shown. From the Venn diagram, we can see that, now here's the important bit here. This is saying that the amount in A, the union of B, so the total amount of things here, is equal to the number in A plus the number in B, subtract the number in the intersection point. So you have to subtract away the number in here. Now, why is that the case? The reason why is because as the intersection has been counted twice in both the number in A and the number in B, we must subtract it. So because we've counted everything in A, so if I use different colors here, it might be a bit helpful. I've counted, let me get rid of that. I'm counting everything in A. So the number of elements in A, I'm counting that. And then I'm going to count the number of elements in B. So the number of elements in B. Do you see that we've counted the intersection part twice? So what we need to do is now subtract that away to find the amount that is here altogether. So we have to subtract it away, otherwise we've counted it twice. Now, this doesn't just account for things like the amount of element, it also applies for the probability as well. So the probability of A, the union of B, is equal to the probability of A plus the probability of B minus the probability of the intersection. This is called the addition rule for combining probabilities. This rule also applies in situations where the outcomes are not equally likely. It is always true. So it's always true. That's what it is. We're now going to go through a bunch of examples where you're going to see it in action.